back, guys. We're on number 8. It says which value of x, or what value of x makes the equation true? So to solve a rational function, it's much like, we're on number 8, solving is much like simplifying. We're generally going to have to find the LCD unless it already has one. So to find that, we're going to factor and then multiply by any missing terms. Any missing terms by what's missing in the LCD. So we have 2 over x plus 4 equals a 6 over x squared minus 14. Oh, this is also a typo, guys. Remember, I said this should be a 16 right here. Okay, so we've got 2 over x plus 4 equals 6 over x squared minus 14. I'm sorry, 16. 16, right? It's a typo. So we're going to factor this one. This one does not factor. It's linear. This one factors as x plus 4, x minus 4. So our LCD is x plus 4, x minus 4. Right? We need an x plus 4, and we need an x minus 4. This one's missing the x minus 4, so I'll multiply both the top and bottom by x minus 4. Don't forget to distribute. That gives you 2x minus 8 over your LCD equals 6 over the LCD. Now, it's nice because the second step is just to drop that LCD. Why are we dropping the LCD? Well, imagine I multiplied both sides by this. They would cancel. And then I multiplied this side by the same thing. It would cancel. So our LCDs cancel out. We're left with 2x minus 8 equals 6. To solve this, we would move the 8 over. Oh, and so 3 is solve. We'd move the 8 over, so that gives us 14. X equals 7. The last thing is to check, because it's possible that this value could make the rational function undefined. So you check it back. It doesn't, right? 7 is okay here. 7 is okay here. So x equals 7 is our solution. Another method that you might want to try, I mean, it's a proportion. You could cross multiply. Let's see how that would look. If I cross multiplied here, I'd have 2 times x squared minus, remember this is 16, equals 6 times x plus 4. And then we would distribute 2x squared minus, that would be 32, equals 6x plus 24. And then we would have a quadratic. So because we have a quadratic, we would need to set everything equal to 0. So I would move everything over to one side. And I would have 2x squared minus 6x minus, oh good lord, 56 equals 0. Now since I have a 0 on the other side, I can divide everything by 2. I get x squared minus 3x minus 28 equals 0. And then I can factor this. That gives me negative 28 and negative 3. So negative 7 times positive 4 is negative 28 and adds to negative 3. So I would have x minus 7, x plus 4 equals 0. Then I'd have x equals 7, x equals negative 4, and I'd need to check. And this value would make my denominator 0, so this would be an extraneous solution. So if you want a second method to do this problem, you could use cross multiplication. Just you have to think back to math 2 when you did that, right? Cross multiplication gives us this green line right here. All right. Which of the following expressions is the sum of the series 6 plus 8 plus 10 plus 12 and so on all the way to 20? All right, one way to do this, you could identify the common difference, d equals 2. Oh, well, first you have to decide if it's arithmetic or geometric. So arithmetic versus geometric. Geometric, you're multiplying by the same number. Arithmetic, you're adding the same number. Now remember, you could be adding a negative, so it could be that d is plus or minus something. And here you could be multiplying by a fraction, so you get r is equal to some value. It could be a whole number or a fraction. In this case, I see there's a common difference. It's going up by 2, up by 2, up by 2. So it's arithmetic, right? D equals 2. So after we identify D equals 2, one way you could do this problem is to plug in your values, plug in your terms. So like n is 1, n is 2, and see which of these is true. So I'm going to try that method for you, and then I'll show you the method that I would prefer. So like when n is 1, I should get that an is 6. So if I plug in to the first function 2 plus 4k, I do get 6, but you have to plug in more than one value. So try n equals 2. And in this case, oh sorry, this is a1, right? a2 would equal, it's supposed to equal 8. If I plug in 2 into the function, the first one, a, 2 plus 4k, that's 8 plus 2, which is 10. No, it's not true, right? I should have gotten 8. So it's not A. You can do the same thing with B. I'll do it again. So now this is not true. Let's try the next function. When n is 1, a1 should be 6. When n is 2, a2 should be 8. So I'll plug it into 4 plus 2k. This is on B, right? So 4 plus 2 times 1, it does equal 6. When we try it for the next value, 4 plus 2 times 2, it does equal 8. So now you might be tempted to select this one, so you need to check it for another value. Oh, I see. No, I'm sorry. Because there's no parentheses here, I would only add 2 at the end, so it would work for the first one, but it would not work for the second one. And also this is confusing to students because it looks like it does work. And so it looks like B is the answer. And so if you kept going with C though, C would work as well. And then D, you keep doing this method and D will not work. So rather than using this method, which you might get confused about, instead we're going to talk about the arithmetic explicit formula. So the explicit formula is an equals a1 plus n minus 1 times d. I'm going to go ahead and create my formula. An equals a1. a1, we didn't identify it, so let's go back. a1 is 6. So that'd be 6 plus n minus 1. Remember, n is supposed to be a variable. And then times d. d is 2. And then we would distribute through. 6 plus 2n minus 2. Combine like terms. This is 4 plus 2n. So it looks like, again, either B or C could work. And so why is this answer C and not B? All right, so the answer to that question is when you have this symbol, summation notation, if you don't put parentheses around your function, what you would be doing here, let me show you what B would look like. B would be 4 plus 2 times 1 plus 2 times 2 plus 2 times 3, etc., etc. You would only add the 4 one time. C, however, would be 4 plus 2 times 1 plus 4 plus 2 times 2 plus, and so on. And so you notice that this term should be your first term, and it is not. And this term should be your second term, and it is not. However, this term should be your first term, and it is. And this term should be your second term, and it is. So always, you do need the parentheses on these kinds of problems in our class. Now later on in a higher math class, you might see times where you don't need parentheses, but in our class, we will almost always need those parentheses. All right, otherwise our values here would be very different. Okay, the first term in a geometric sequence is 2. So geometric, right, the common ratio is -3. Write the explicit and recursive formula. So geometric explicit is an equals a1 times r to the n minus 1, and then recursive is an equals a n minus 1 times r. And then if r is a fraction, I'm going to put parentheses. If r is a fraction or negative, you need parentheses anyway. Okay, so in this case, our explicit formula would be an equals a1. a1 is 2. So 2 times r to the n minus 1, and r is negative 3. Done. Now with recursive, I want to remind you, you always need to mention what a1 is. Otherwise, this formula is useless. So an equals a n minus 1 times negative 3. Done. But we need to mention that a1 is 2. All right, so there's the explicit formula, and this is the recursive formula, including our a1. All right, I'm going to stop the video here. We will pick up with number 11 on the next video.